Hello friends, a very good morning to all the students. Am I audible to all the students? Okay, fine. Thank you all for the responses in the chat box. So dear friends, we are aware that we are discussing the chapter that is an important chapter of the subject of basic mechanical engineering. We are discussing the third chapter, that is the properties of gases. And in the last lecture, we have completed the theoretical aspects or the analytical aspects of the chapter of the properties of the gases. And also I had instructed you that from the next lecture onwards, we are going to solve the numericals of the properties of gases. And friends, remember, properties of gases numericals are very important because in the GTU examination always one numerical is asked from this chapter, and that one numerical will be having 7 marks. One 7 marks numerical is always asked from the chapter of the properties of the gases. So dear friends, try to focus on the points which I am discussing in the numericals and try to calculate the answers at your level. I hope you are ready with your notebook, pen and the scientific calculator. If you are ready, kindly give me your responses in the chat box so that I can proceed further in this lecture. Okay, very good. So majority of the students are ready for the lecture. So first friends, before actually starting the numericals, before solving the numericals, first we need to remember some of the equations which we are going to use in the numericals. So you can kindly note down the equations because all these equations we are going to use frequently in solving the numericals. So the first equation that we have studied several times, also I have discussed this concept several times in this chapter, that is the Boyle's law. The standard equation for Boyle's law, that is PV is equal to constant. If I am writing this equation at initial state 1 and final state 2, then I can write down P1V1 is equal to P2V2, where 1 represents the initial condition of the gas and 2 represents the final condition of the gas. Moving further, also we have studied the Charles law, and in the Charles law we have studied that the standard relation, that is V by T, is equal to constant. So similarly at initial state 1 and final state 2, I can write down the equation, that is V1 by T1 is equal to V2 by T2. Also we have studied and made the derivation, that is the combined gas law. So combined gas law, the equation is PV by T is equal to constant. Similarly, at the initial states 1 and the final state 2, the combined gas law can be written in this particular format, that is P1V1 by T1 is equal to P2V2 by T2. Also, we have studied the equation of state for a perfect gas or the perfect gas equation, that is PV is equal to mRT. And dear friends, highlight this point. This is one of the important equation which we are going to use frequently when we will be solving the numericals. So PV is equal to mRT. where now let us understand the notations and their units, where P represents the pressure of the gas that always will be taken in Pascal or Newton per meter square, that is the SI units. Capital V represents the volume of the gas that is considered in meter cube. M is equal to mass of the gas that is taken in kg. Remember friends, this is small m. So small m we are considering the mass that is always taken in kilogram, that is kg. Capital T, that is the temperature of the gas, and temperature of the gas in the SI units. We are going to convert it into Kelvin scale. And finally capital R, that is equal to the characteristic gas constant, and the value of R we are going to take in joule per kg Kelvin. I hope dear students you have understood up till this point. This is just a quick revision of all the theoretical derivations which we have studied previously. I hope you are mentioning all these points in your notebook. I want your responses in the chat box so that I can proceed further. Okay, fine. Many students are giving me the answer in the chat box. Okay, friends, so let us proceed further. Also, we have studied the characteristic gas equation, that is PV is equal to RT. But in this equation, we have considered volume, that is the specific volume. And we are knowing that specific volume is equal to total volume divided by mass. So the unit of specific volume will be meter cube per kg, total volume divided by mass. Then we have understood the most important question of this chapter, that is the relationship between Cp and Cv, and the relationship is known as the Mayer's equation. So Cp minus Cv is equal to capital R, where Cp stands for the specific heat of the gas at constant pressure conditions. We need to take this value in joule per kg Kelvin. Similarly, Cv is equal to the specific heat of the gas at constant volume conditions. Again, take this value in joule per kg Kelvin. Capital R we have already understood previously. Also, we are knowing that the ratio, that is Cp by Cv, is equal to gamma, and the value of gamma is always constant, that is 1.4. And in theory, we have understood gamma, that is also known as the adiabatic index. So using these two relations, that is the Mayer's equation and Cp by Cv is equal to gamma, we are getting the answer, that is Cv is equal to R upon gamma minus 1, and Cp is equal to gamma R upon gamma minus 1. Remember friends, in these two equations, that is capital R characteristic gas constant and gamma, that is constant, that is 1.4. Now the most important point which you need to remember always in the numerical, your pressure will be given in bar. So we need to convert that bar into the standard SI unit. So this is the conversion, that is 1 bar is equal to 10 raised to power 5 Pascal or Newton per meter square. Dear friends, do not make the error in the pressure, just highlight the point and remember this conversion. Also, we need to convert the temperature which will be given in degrees Celsius into the Kelvin scale. So this is the equation for the conversion. Temperature in Kelvin, that is equal to temperature in degrees Celsius plus 273. Dear students, I hope you are understanding these points and you are noting down the points and also highlighting the important points which I am discussing in the lecture. Okay, fine. Majority of the students has replied me in the chat box. Okay, students. So moving further, this is again the important concept, that is the sign convections between the heat and work. We have studied in chapter number 1, thermodynamic system surrounded by the boundary which covers the system, and outside the system, that is known as the surroundings. The heat energy entering to the system is considered as positive, and the heat energy leaving the system is considered as negative. And for the concept of work, it is completely the opposite. When the work is done on the system, it is considered negative. And when the work is done by the system, it is considered positive. So kindly draw this diagram in your book, because several times we are going to use these logics in the numericals. Okay, students, have you completed up till this point? Have you drawn this diagram? Kindly give me your responses so that I can proceed further. Very important point, the sign convections between the heat and the work. While solving, you will be getting the positive values as well as the negative values. So do not worry about the positive and the negative values. Okay, thank you all. So moving further, these are the most important equations for the different non-flow processes, and dear friends, no need to mention these equations because this is the same image which is given in your textbook. So in the textbook, this particular chart you need to remember for the different non-flow processes. The constant pressure process, also known as isobaric, the governing relations are given. Then Q is equal to the equation W, that is equal to PV2 minus V1, and the standard relations for delta U and delta L. Similarly, for the constant volume process and the isothermal process, no need to write down this equation, no need to write down this table, because it is already given in your textbook. So you need to remember this particular table. And if you are perfectly understanding these equations and the table, then you can easily solve any numerical of the chapter of the properties of gases. So three processes, the equations are mentioned in this image. The fourth and the fifth one, that is the adiabatic process and the polytropic process. Only the difference is in the adiabatic process, we are considering gamma, that is constant adiabatic index. For the polytropic process, we are considering small n, that is the polytropic index, and it is the variable. For adiabatic process, heat interaction Q is equal to 0. But for polytropic process, Q is equal to gamma minus n upon gamma minus 1 into W. Rest all things remain the same, only the gamma is replaced by small n. So now friends, let us proceed further with the first numerical, very simple numerical. And remember friends, whatever numericals I am discussing in the lecture session, all the numericals are asked in the GTU examination. And all these numericals are asked for 7 marks. So we need to follow a particular format of the presentation in solving the numericals. And this is the standard format I will be using in each and every numerical in the subject of basic mechanical engineering. Also, I suggest you students to follow this format because it will be easy for you to understand the numerical. Also, it will be easy for the examiner to check your paper, and you will be getting good marks, maximum marks in the numerical. So let us proceed further. First, you are given the ideal gas is heated from 25 degrees Celsius to 145 degrees Celsius. The mass of the gas is given 2 kg. Determine the specific heats. Okay, no need to write down the question in the notebook. Just you can understand the question and you can start with the solution. Okay, first try to understand these steps. No need to hurry in mentioning in the notebook. Determine the specific heat, the change in the internal energy, the change in enthalpy. Assume capital R is equal to 267 joule per kg Kelvin. And gamma is equal to 1.4 for this. So in the examination, this type of the numerical will be given. You need not to note down this numerical. You can directly start with the point of the solution. So write down the solution with the good handwriting, bigger handwriting in your notebook. Then you can mention step number 1. Very important point in the presentation. Step number 1, that is given data. So we will now write down the given data in a very good manner, understanding the numerical. So first given data which is mentioned in the numerical, that is an ideal gas. Then we are given the initial temperature of the gas, that is T1 25 degrees Celsius. Converting degrees Celsius into Kelvin, so 25 plus 273, that is 298 Kelvin. This gas is heated to the final temperature. So the final temperature of the gas, that is T2, is equal to 145 degrees Celsius. Again converting this value into Kelvin. The mass of the gas is given, that is M is equal to 2 kg. Also we are given the value of capital R, that is 267 joule per kg Kelvin. And gamma we are given, that is 1.4, is always constant. So this is the step number 1. Now friends, writing down the second step, step number 2, that is to find what we are asked to calculate in this numerical, that we will be mentioning in this step. So step number 2, that is to find. So the first we are asked to calculate the specific heats. We are knowing that there are two values of specific heat, Cp and Cv. Then we are asked to calculate the change in internal energy, that is delta U. And third we are asked to calculate the change in enthalpy, that is delta H. I hope you have understood the format for the presentation and how we are doing the notations, how we are changing the units to the SI units. If you have understood both the steps, kindly give me your responses in the chat box so that I can proceed further in the lecture. All the students, kindly give me your responses in the chat box if you have understood both these steps. Very easy to understand. Just you need to clear your logic in the numerical. You can easily note down these two steps. But remember, we need to convert the values in the standard SI units. Now friends, moving further in step number 3, that is the calculations. So first we will be writing down the specific heat at constant volume, that is Cv, which is given as Cv is equal to R upon gamma minus 1. We are already knowing this equation. Substituting these values, we are getting the answer, that is 667.5 joule per kg Kelvin. Remember friends, for every answer we need to mention its unit. If you are getting some other answer than this, but your answer must be near to this answer, then it is okay, no need to worry for that. You can get the answer 668, then also it is correct. You can get the answer 666, then also it is correct. Moving further, the specific heat at constant pressure, that is Cp, is given by Cp is equal to gamma R upon gamma minus 1. Also for calculating Cp, you can use the Mayer's equation, that is Cp minus Cv is equal to capital R, or you can use Cp by Cv is equal to gamma. Any relation you use, you will be getting the same answer. So the answer of Cp we are getting, that is 934.5 joule per kg Kelvin. So now writing down the answers in the specific format, good format. Thus the specific heats of the gas are as follows, which we were asked to calculate. Cv is equal to 667.5 joule per kg Kelvin. And Cp is equal to 934.5 joule per kg Kelvin, and this is the answer. On the right hand side, in the big handwriting, you can mention that this is the answer, or you can make the box of it. so that it is highlighted to the examiner who is checking your paper. I hope, friends, you are getting these answers and you are understanding the format for the presentation for scoring good marks. Kindly give me your responses in the chat box if you are understanding the points and you are getting these answers. Kindly share your responses in the chat box. Okay, fine. Thank you all. So, moving further, now we need to calculate the change in internal energy delta U. We have studied this equation several times, only one relation for delta U. So, delta U is equal to mCV T2 minus T1. We are having all the values, substituting these values in the equation. We are getting the answer, that is delta U is equal to 160.2 into 10 raised to power 3 joule. Remember, friends, how to get this 10 raised to power 3 joule. In your calculator, you will be having one key, that is E and G. Capital E and G will be written. So after calculating the answer of this equation, whenever you are pressing that key of E and G, you will be getting your answer in terms of 10 raised to power. So if you are pressing the value of E and G after calculating this equation, then you will be getting the answer in this form, that is 160.2 into 10 raised to power 3. And unit of internal energy, it is a type of energy, that is joule. So 10 raised to power 3, I can convert it to the kilojoule. So now my final answer will be the change in internal energy for the gas, that is delta U is equal to 160.2 kilojoule. That is my final answer. If you are writing in joule also, then also no problem. You will be getting the full marks. But this is the standard procedure of presenting the answer. If you can convert that answer in another unit, if it is possible, then you need to convert that answer. Now friends, moving further, calculating the change in enthalpy, that is delta H. Standard relation, delta H is equal to mCp T2 minus T1. We are already knowing all these values, substituting in the equation. We are getting this answer, that is 224.28 kilojoule. So this is my final answer, that is the change in enthalpy of the gas, that is delta H is equal to 224.28 kilojoule. I hope you are getting all these answers and you have understood this numerical. This is the end of the numerical. We have calculated all the unknown values which were asked in the numerical. If you are getting all the answers, kindly give me your responses in the chat box so that I can proceed further with the next numerical. Okay, thank you all for your responses. So now moving further to the second numerical. Here it is given 5 kg of air is heated from initial volume of 0.5 meter cube to the final volume of 1.3 meter cube at constant pressure of 4 bar. Determine number 1, the heat supplied, number 2, work done, number 3, the initial and final temperature of air. Take Cp is equal to 1.005 kilojoule per kg Kelvin and capital R is equal to 0.287 kilojoule per kg Kelvin. Very simple numerical, ask the GTU for 7 marks. So let us start with the solution. Now I hope you are perfectly clear about the presentation method. So I will be proceeding in somewhat a faster rate. So you need to just mention all these points. So step number 1, that is given data. First, we are given the mass of the air, so small m is equal to 5 kg. Then we are given the initial volume of the air, that is V1 is equal to 0.5 meter cube. Then we are given the final volume of the air, that is V2 is equal to 1.3 meter cube. Then one important point, constant pressure. So this is the constant pressure process, isobaric process. So I can write down for constant pressure process, initial pressure is equal to final pressure, P1 is equal to P2. That is given in bar, that is 4 bar. So converting this bar into Pascal, so that is 4 into 10 raised to power 5 Pascal. Very important point. Remember friends, converting the bar into the Pascal. Then we are given the value of Cp, that is 1.005 kilojoule per kg Kelvin. So again converting the kilojoule into joule. So that is 10 raised to power 3 joule per kg Kelvin. And similarly capital R also converting in joule per kg Kelvin. So these are the points we have mentioned in the given data. Proceeding further, step number 2. Here firstly we need to calculate the amount of heat supplied, that is Q. Then we need to calculate the amount of work done, that is W. And third, we need to calculate the initial and final temperatures of the air. So temperatures are T1 and T2. I hope friends you have mentioned these steps. Okay, one student is asking, sir, which button we need to press? Okay, so whenever you are getting the final answer, just press the key which is written capital E and G. If you are pressing that key of E and G, you will be getting your answer in terms of 10 raised to power 62 number. Have you understood the point? Okay, fine. So all the students has written both these steps. So now let us proceed further in the third step, that is of the calculations. So according to the equation of state for a perfect gas, that is at initial state 1, I can write down P1 V1 is equal to MRT1. So from this equation, I will be calculating the value of T1. So dear friends, dear students, kindly give me the answer of T1 with the unit. Also, you need to mention the unit of T1, the numerical value and the answer of T1. If you have calculated, kindly share your answers in the chat box. Okay, some of the students have already posted their answers. Roll number 91 has given me the answer. Roll number 93 has also posted his answer. All other students, kindly post your answers in the chat box so that I can able to understand how you are calculating. Okay, very good students. So in this case, majority of the students has given me the same answer, the perfect answer. So on substituting these values in this equation, we are calculating the answer, that is capital T1 is equal to 139.37 Kelvin. So this is the first parameter we were asked to calculate. Thus the initial temperature of the air, that is T1 is equal to 139.37 Kelvin. Moving further, since it is the constant pressure process, we can apply the Charles law. So I can write down the equation according to the Charles law, that is V1 by T1 is equal to V2 by T2. Substituting all these values, I am getting the answer, that is T2 is equal to 362.36 Kelvin. This is the final temperature of the air. So T2 is equal to 362.36 Kelvin. Okay, I hope you have got these answers very easy to understand. Let us proceed further. in calculating the other parameter. Now the amount of heat supplied for the constant pressure process. So for the amount of heat supplied for the constant pressure process, we can write down the equation, that is Q is equal to mCp T2 minus T1. We are knowing all these values. So Q is equal to 5 Cp 1.005 10 is to power 3 T2 minus T1. Substituting the values of temperature, we are getting the answer Q, that is equal to 1.1205. Doing the E and G, getting the answer into 10 raised to power 6 joule. So I can convert 10 raised to power 6 joule into megajoule. And since we are getting the positive value, we will be mentioning the comment. The positive sign shows that the heat is absorbed by the air during the process according to the sign convections, which I have already discussed in this lecture. So the final answer, now the amount of heat supply, that is Q is equal to 1.1205 megajoule. That is the final answer. Dear students, are you getting this answer? Have you understood how I have mentioned this statement of the comment since I am getting the positive value? Kindly share me your responses in the chat box. So for Q and W, we need to mention the comments. So now we will be calculating the amount of work done during the constant pressure process. So that is W is equal to P1 into bracket V2 minus V1. Substituting the values of P1, V2 and V1, we are getting the answer, that is W is equal to 320 into 10 is to power 3 joule. Converting 10 is to power 3 joule into kilojoule. Here in W, we are getting the positive value of W. So positive sign shows that the work is done by the air during the process. Remember friends, here the thermodynamic system is the air itself. So the work is done by the air on the surroundings. So hence the answer comes out to be positive value. So the final answer, that is work done W is equal to 320 kilojoule. I hope you have understood this numerical perfectly. I want your responses in the chat box. Dear students, are you getting the points? How we are solving? Okay, majority of the students has given me the answer perfectly, that they have understood. So friends, let us proceed further to the third numerical. And this numerical, now you have to calculate by your own. And after some few minutes, I will be showing you the answers of this numerical, so that you can cross check whether you have got the right answer or you have got the wrong answer. So try to understand the numerical perfectly, try to understand the values which are given, convert these values in the standard SI units, and then you can proceed further to write down the given data to find and then start the calculations. In this numerical, only two parameters you need to find out, that is the amount of heat transfer and the amount of the work done. Understanding the numerical, you will be seeing that it is a constant pressure process. So we need to take the equations of Q and W of the constant pressure process. All other values are given in the numerical. So try to understand the numerical and then proceed in order to calculate the value of Q and W. If you are stuck somewhere, if you are not understanding any point in this numerical, kindly share your doubt in the chat box so that I can clear your doubt and you can proceed further in the calculations. I am observing that I am not getting any of your responses or doubts in the chat box. That means all the students are understanding and they are calculating the answers. Okay, so for your reference, I am just showing you the first answer of the calculations which you need to calculate first. So first you need to calculate the mass of the gas. The value of m you need to calculate because it is not given in the numerical. So the mass of the gas m comes out to be 0.2234 kg. How I have calculated the mass using the equation of state for a perfect gas. P1 V1 is equal to mRT1. Using that equation, I have calculated the value of mass m. If you have got the value of mass m, then you can easily calculate the amount of heat transfer per constant pressure process. The equation is Q is equal to m Cp T2 minus T1. All other values you are already given. So the first answer of this numerical comes out to be the amount of heat transfer, that is Q is equal to minus 39.290 kilojoule. Let me know how many students have got this answer. Kindly share your responses in the chat box if you have got the same answer. Q is equal to minus 39.290 kilojoule. Okay, I have got the responses from roll number 50. Fine. Okay, you have got this answer. Very good. So what about the other students? Are you getting this answer? Okay, answer is minus. Okay, very good. 85 number, that is the same answer. Minus 39 point something. Okay, roll number 55 has also got this answer. Roll number 91 has got this answer. Very good, students. Roll number 63 has also got this answer. Very good. So the first answer we have reached, that is minus 39.290. Here we are getting negative sign. So we need to mention the comment. The negative sign shows that the amount of heat is released by the gas during the process. Negative sign shows that the value is reducing. So this is the amount of heat which is released by the gas during the process. Proceeding further, next we need to calculate the amount of work done, that is W. So equation for W, that is P V2 minus V1. So firstly we need to calculate V2. So final volume, that is 0.0622 meter cube. Substituting these values of V2 in equation for W, we are getting the answer, that is minus 11.34 kilojoule. Again the negative value of W. So we will be mentioning the statement negative value shows that the work is done on the gas during the process. When the work is done on the system, we are considering the negative value.